So, hello everyone. My name is Guy Teverovsky. I'm the CTO for Semperis, and today we will be talking about resurrecting domain controllers. Now, back then when we were planning with Semperis the sessions, Mickey came to me, you need to talk. You need to deliver a session. And I was, yeah, sure, all right. And then I got swamped in the work. And we were getting closer and closer, and I still didn't have a topic. So, but I was working on something. We Semperis are doing for a AD recovery product. So I was working on something, and the time was pressing. And I ended up going like, why don't I just talk about what I'm doing right now? I'm working with developers. We are implementing something new. Let's just take those concepts and present them. Let's talk about them. Now, Michael started this. Actually, we were talking about this last year. We were co-delivering a session, and we started talking about this thing. What do you do when you don't have backups, when your domain controllers are gone, well, you have been left with almost nothing. You maybe have your database and a couple of files. How do you recover from this? And there basically were two approaches to this. The first approach, you have seen Michael talk about this, basically kind of injecting the DIT into a new server. But there are a couple of challenges with this. If you take that way, there are a lot of corner cases that you need to take care of. Basically, one of the things that you saw, which is kind of not really straightforward, is reinjecting those SIDs into their local registry of the server, basically because it's a new forest. So you have promoted domain controller, then you inject something on top of this, but the local registry thinks that has those leftovers, right? So, and we as Semperis try to think about a slightly different way. And we will be basically we'll try to go through the phases, and we'll kill a domain controller. We'll take a new server, and we'll go through the steps necessary to recover it, basically restore. We'll have a new domain controller. We will be transplanting the domain controller personality from one server to another. So when could we encounter a situation when we need that? That could be hardware failure. Usually you won't see that happening to larger customers, but there are a lot of small customers with maybe 1, 2 domain controllers. Something happens, or sometimes you have those smaller isolated environments that sometimes IT say that they're not critical, but when they go down, suddenly they realize that there was some sort of line of business application depending on that single domain controller, and now it's gone. So it could be software failure and ransomware. Well, I just don't want to repeat what has been already said. Domain controllers have been encrypted. An additional scenario that I can think of is the challenge of restoring domain controllers. Let's say you need to restore. You've been owned. Your environment has been owned. What is the standard way of recovering your domain controllers? Anyone? Sorry?
Authoritative restore?
Authoritative restore, but what do you need for that?
You need a backup.
you need backups. And what sort of backups? Well, obviously, but system state, right? At least you need the system state. But what does system state contain?
Registry.
Okay. So I have a bunch of slides, right? But I have no intention of really using the slides because the whole purpose of this session will be the demo. So just ignore it for a second that I'm jumping around. The system state has a lot of information. It contains registry, it contains COM+ database, it contains WMI, schema, scheduled tasks. If you have CA installed on that server, it will have their PKI-related CA database, et cetera, et cetera, et cetera. So a lot of things will be included in the system state. But here is the thing. There is the system writer, the generic system writer, that will contain, among other things, a huge chunk of binaries and executables. So basically, C, Windows System 32, a lot of DLLs and executables will be part of that system state. So what does that tell you? What happens if you restore using those backups? And you are suspecting that your domain controllers have been...
Oh, sorry, I thought you were actually asking them a question.
Oh, yeah, well...
No, I just meant, like, if it's compromised, then it'll be compromised on restore.
You're re-injecting the threat, right? So you are trying to recover, and you are reintroducing the threat into that environment. So we were trying to figure out a way to restore domain controllers and take the bare minimum. Basically take only the data without pulling all those binaries from their original domain controller. And, well, let's just think for a second. What makes a domain controller a domain controller? You have, come on, people, come on. It's there. It's written on the...
We have to read it out loud to you. System state.
There are basically roles and features. Roles and features are the binaries on the disks. On the disks are the Windows services that need to run, right? And there is the system state. Well, but essentially, it's the database, Active Directory database. It's the sysvol. It's the configuration of the services, et cetera, et cetera, et cetera. But again, system state, it's too much. System state is something generic. System state you can use if you need to restore any Windows server. But we are talking about domain controllers. Domain controllers are special. And in this case, we wanted to have something like Swiss Army knife, kind of isolated. And we wanted to go deeper. So we will be doing autopsy on the domain controller. We'll try to figure out what do we need to actually inject into a new server to make it a domain controller. And if we are successful, we will kill one domain controller, and we will revive another server with the identity of this originally dead domain controller. So, tools. And here's the thing. When I started, I thought that I will just write some code and maybe do some tool. And eventually I said, we'll try to do it the kind of hardcore way. Let's use the tools that are available on the server. Let's use things like regexe, mount wall. Well, we will be using a couple of tools from system internals like psexec, junction to recreate junction points. And I think there is one instance when we will be going to PowerShell. There is only one thing that involves custom coding, and this is, we will get to this. So let's just introduce the environment. We have 3 servers. There are 2 servers that are currently configured as domain controllers. And one server is a kind of, let's call it a standby server, fresh install. It has nothing installed in it. So let's take a look. 2 domain controllers, this query, sure, you can probably figure out by that time that I'm command line frick. 2 domain controllers, there is some data in AD, less important. They're living fine. Now, let's just be brutal. We'll be killing the first domain controller, right? There is only one thing that I did before this. I took a backup of one of the domain controllers. And when I say backup, it's not the actual system state backup. I copied some of the files of that domain controller. Let me just elaborate and show you. So we have an additional server, the 3rd server. Currently, oh, come on. That's its name, Win2K16 SRV01. It's not a domain controller. It doesn't have AD roles installed. No. Workgroup. It's a fresh install of Windows operating system, bare minimum, right? And this is going to be our target. This is where we will be injecting the Active Directory. So I took a backup of the first domain controller in our environment, and basically what we have is the DIT and TDS DIT contents, right? We have the sysvol contents, right? And we also have some information from the operating system itself. Now, the only must-have thing that is required is the registry hives. Anyone knows why do we need the registry hives from the original domain controller? And so that
You need a SIS key?
exactly. So the secrets in their AD database are encrypted using something called PAK, password encryption key. PAK itself is stored in their, anyone? No. It's stored in the database itself. But the PAK is encrypted using SIS Key. So basically that means that AD database is not really portable by default. You can't just copy it from one domain controller to another. because in order to access the secrets in the database, you need the original SIS key, right? But, well, one option is to use the offline tools and to take the pack, decrypt it using the original key, and re-encrypt it using a different key. This is the approach that Michael took, right?
Do you need all the items?
No. But it's kind of nice to have, and we will be doing this on the way, and we'll be talking about what benefits each additional file or service introduces. So the bare minimum that you need is the system Hive. If you take this approach, security and SAM Hives, plus the DIT. Syswall is very nice to have, but what happens if your syswall is gone? Will the domain controller come back to life? Yeah, if you basically can recreate the default GPOs, right? It's the price you will pay. But if it's a total disaster, if you have no other options, yeah, so you will still be able to gain access to the original contents of AD. You will lose the GPOs. So there are a lot of things that will be restoring that are kind of optional. So okay. Now, we will just, what do you guys want to do? We'll shut down or delete the VM?
Just delete it.
Delete the VM. Let's go brutal, right? Delete.
Think you wants to turn off?
Turn off. Okay. And this one. And delete, right? This domain controller is officially gone.
Oh, no.
So, oops.
Did you take it back up?
No backup. So we go back to the second domain controller as, let's see, what does it think? The query server, it thinks that there are supposed to be two domain controllers. But, oops, it cannot replicate with its replication partner. Now, the reason that we have two domain controllers in this environment is that, bless you, I wanted to show you that after we revive our domain controller, the domain controller, it will be replicating with this one, right? Because, well, otherwise, what's the point? We read. So let's go to the patient. We'll start with, well, what do surgeons start with? Discovery surgery. So we'll do some discovery. We will mount the system Hive of the domain controller. And just a second. No. Not yet. No. Here we go. So, and let's take a look. So I have loaded the system Hive of the original domain controller, right? There are some things that we will need from there. So first of all, we could take a look at the configuration of the services. So let's see, for example, in TDS parameters. From here, we can learn things like where did the Active Directory database reside, on what drive, right? What was their configuration partition, the name of the configuration partition, the distinguished name of the configuration partition. There is some additional information here that becomes useful. There are actually two things that are dynamic here. If you look at DS drive mappings, actually this is an interesting one. What it does, it basically maps the drive ladder to the volume GUID of the disk on which the database resides on. So basically, if you have Active Directory database on multiple, you have database on D drive, you have logs on E drive, you have sys, syswall is not relevant here. So basically, DE drive, you will have two entries over here, one for D, one for E. It will be mapping between the drive ladder to volume GUID. Now, we are going to use a different server. The volume GUIDs are going to change, right? Now, the thing is that I'm pretty sure that by default, those drive mappings are not being used. And my suspicion is that if drive ladders change, this registry key is being used as a hint to try to figure out where the actual database is located. But still, we want to do it properly, so we will be taking a look at this. There is an additional thing, database epoch. DSA database epoch. What happens is when their Active Directory database is mounted, there is an entry in the database that specifies the version of the currently running database. The same version is written to the registry. If there is a mismatch between those two numbers, the NTDS service will not start. So we need to make sure that those match, right?
There's a red key you can set so it skips that check.
Yeah, well, that's another way of doing this. Another thing to take is, well, the name of the server. We can go to services, TCP parameters, and you will see that we have NV domain that reflects the name of their domain that the domain controller was part of. And there's host name. So at that point, by the way, this server has a different name, right? So and well, at that point, we know what was the name of the server. Of the domain control, we know where the Active Directory database was located. We have the registry Hive. So we can start, right? And the first thing that we will do is, well, we will try to stop all this kind of majority of the Windows services. We don't want them to interfere, right? We'll try to put the server into, how do you say, we'll call that induced comma, right? So we'll try to put that server into a comma. We'll start with, now here's the thing, we want to have privileges. We will be operating on a live server while it's still running. One of the things that we wanted to achieve was to be able to operate on a live machine. without without rebooting, without requirements for for ability to boot from another operating system or network boot, whatever. So we will be running as system. For that, we will be using psexec. So I'm currently running as a system, right? At that point, I have enough privileges. We'll start with stopping the services. And the reason we do that is because we don't want those services to interfere with things that we are going to do. Well, one great example is Windows updates. If you try to do something on the server and in the middle Windows update tries to install something, patched server, you could end up with the server in an inconsistent state. Now, I think that I have just missed one important step, and it's installing their actual Windows roles that we need. So we could now run into an issue. Come on. No? PowerShell. Sorry? Yeah, this one didn't stop, right? The last one. So we'll start with installing the basic AD-related services, AD-related roles. We're installing GPMC, ADDS tools, and RSAT tools. Okay, the bare minimum. This might take a couple of minutes. Now, it's pretty fast. Okay. So we have a DDS role installed. If we try the server manager, one of the things it will do, it will give us an option to, promote this domain controller, right? But we are not going to do that. At that point, we have all the binaries on the disk, and we will be injecting the state of the domain controller. So we'll start with the basics. One of the reasons that we didn't want to take the approach that Michael used was the fact that domain controller is just sometimes has more than just database and sysvol. Sometimes when you're recovering domain controller, you also need to recover things like that were part of that domain controller. Now, the encryption keys that are stored on the disk are encrypted using DPAPI, right? DPAPI requires the LSA keys, right? LSA secrets. If your are re-encrypted it, and you're basically working with a server that has a new set of LSA secrets. So it won't have access to the original encryption keys that the server had. So we wanted to overcome that. And, well, any ideas what can be done? Where are the LSA secrets stored? Security Hive. But Security Hive comes together with, it's kind of paired with SAM Hive. You're not supposed to mix and match, right? So at that point, you end up with, you need Security Hive, you need SAM Hive. Those will have the original LSA keys, and basically that gives you access to the original encryption keys that were stored on disk of the original domain controller, right? So first thing to do, we will be, now if we look at the backup, that domain controller, you will see that system Microsoft. Now, this looks familiar, right, from the previous session. The crypto, protect, basically those are parts of encryption keys that are stored on disk. So what we will do, we will be just copying those from the original location, from backup. Let's just inject those into this server. And for that, we will be using Robocopy, the ultimate backup and restore utility. And, well, there's another thing. DNS stores in some of the information on disk. If you go, for example, to see Windows DNS, or is it 32? System 32 DNS. So sometimes you will, let's say if you have file-based DNS zones, right? Those will be stored there. There are some, if you have customized the routines using the files, there is an option to do that. That will be stored there. So, well, again, this is optional. It's not required. But, well, let's just do that. In our case, I think, not sure we have actual DNS zones, file-based DNS zones, but let's just copy that. And there is another thing, the service profiles. So there is under Windows Service Profiles, if you look at that location, you will see that there are local service and network service. Basically, those are the location of profiles of, well, local service and network service. Again, if there are customizations that have been done to those profiles, they will be stored there. This part is optional. It's kind of nice to have. So let's just copy them. Oh, sorry. Now, if you take a closer look at the robocopy command, you will see that I have an exclusion, right? The XF basically specifies an exclusion. The exclusion is anti-user.star. The reason is that the anti-user.bat files are currently mounted, that they're in use. You can't just copy it. So for that, we have some trick. We have a trick that we will be using later. So we have copied their service profiles. Another important component of the main controller is the COM+ database. Now, COM, for me, it's kind of this black box. Anyone here has a good understanding of COM+ database? No? So I'm not the only one. But the point is that the COM+ database is not stored in the registry. It has its own dedicated database, and it contains, among other things, contains the permissions that are granted to different COM+ components, right? So ideally, we want to bring back the database. Again, this is not a requirement, but COM+ database is located at under C Windows registration. If we look at the current database, C Windows registration, you will see that there is a CLB file there. Let's just override it. So we have one file that, sorry?
I think one of the lines that you had ran didn't execute from the previous one because we pasted over it, I think.
The last one? From the previous?
Yeah, from the previous.
Okay. We can just read around it again. Thank you. Yeah.
Yeah, that did sound cool.
Okay. So now here's the interesting part. It's only 6 files because the most of that was just the structured directories. Those are just vanilla profiles. There is no customization, so most of those service profiles are, well, there's nothing there. Now, COM+, we have copied the database, but it's not enough to just copy over a database. You need to tell the COM+ that this database has been restored. So we go for that to PowerShell. We create a COM admin catalog object. And then there is an API. There is a method that you can call on that object called restore regdb. And you just pass it the path to the COM+ database. That's it. That's how you restore COM+ database. So let's get to the more juicy parts. We are there for the DID, for the main control, right? So one of the requirements in what we're currently doing is to have the same disk layout on the source domain controller and on the target. So this is important. Now, I was actually under impression that we will have time left, but let's see. So TDS, okay, it's there. And then there is the sysvol, right? Now, sysvol, there is the actual content of the sysvol including the structure. And there are the junction points in the sysvol, right? There are 2 junction points in the sysvol. And we need to recreate them. Now, we know the name of the domain, so we know the names of the junction points that we need to create. So in our case, we will be pointing dsysvol sysvol phoenix.local to dsysvol domain. Sorry. So junction is a sysinternals utility, command line utility that allows us to recreate the junction points, or basically to manage junction points. Now, here is a thing. We need to, there are services that were configured on the original domain controller. So what we will do, we'll mount the registry of the original domain controller. I have created a file with a list of services that we are interested in. Now, it's just a list of services that will be copying their configuration on. Now, there is more than actually required, but the bare minimum, you will need DFS, DFSR if you're running DFSR on your domain controllers, DNS if it's also running DNS server. You'll want to copy the LAN-man server if there are shares involved. NetLogon, well, is a must-have. And obviously in TDS, chunk of the registry. So I have this one-liner that goes over the services and does reg copy of the registry key identified by that service. And if we look at the current registry, so current control set, services. Now it thinks that it's a domain controller, right? We have copied. But there is one thing missing. Mount wall. So the D drive, the GUID, volume GUID of D drive has changed. If you just type mount wall, it will also, at the end of the help, it will provide you with the volume GUIDs. Sorry, where is the, here we go. So this is the GUID that we are interested in. So we'll just replace the original GUID, right? What else? Under pressure. Those have already been copied. Now, another thing to note, you can read the contents of the DIT offline, right? We have a command line tool for that we wrote for ourselves. Basically, it goes into the DIT, uses ESC APIs, and just provides some basic information about the DIT. It's pretty useful to kind of get a quick understanding or what database are we dealing with, what was the name of the domain controller, what is the name of what is the distinguished name of the domain partition, etc., etc., etc. The interesting is one of the things that we need from there is the database epoch, and we just need to make sure that the epoch in the database is the same as the epoch on this in the registry. So 21,237, 21,237, it's currently the same. Okay. Another thing, important thing that you want to ideally to copy is the current configuration of the LSA policies. Now this is stored in the registry. It's stored under system current control set control LSA. Now here's the interesting part. There are 4 registry keys there that are used to store the boot key. So do you see the first 4? Those are the registry keys that you don't want to touch using regedit or standard registry editing tools. Those are the keys that actually contain behind the scenes the SIS key. So we are excluding them from the copy. 5 minutes. That will be interesting. So, next one. I will be copying some basic information like computer name and product options. Any NT4 guys out here? Like, let's say you had PDC and you wanted to make it a member server. There is a registry key that you can set that will tell the server that it's not a domain controller. And it's stored under control product options. System control set, control product options. Currently it's server NT, right? Let's just copy the registry keys. Landman NT. Basically, this registry values tells the server that it's a domain controller. That's tough. That will be tough. Okay, let's go faster. There are also 2 places in the registry that contain configuration of TCPIP stack, and there is also the FQDN of the server that is stored in the registry. Do you remember we started by looking at the TCPIP services, right? Services TCPIP. Sorry, system current control set, services, TCPIP, parameters, and, well, now it's already the name of the original domain control. We have overridden that. Okay. Last one, software registry Hive. Now, over here, basically, I'm overriding some parts that are talking about whether Windows file server role is configured, because we started with adding the roles, right? When you install the Windows roles, there are roles that are not configured till you complete the DC promo process. But we are not doing the actual DC promo, so we need to inject some information there in the registry. Well, we want to also tell the server that it has been restored from backup. Sorry. Why is it? Okay. So we'll tell the FSR that it has been non-authoritatively restored. Basically, we'll let the FSR resync the database instead of relying on the actual contents. If it's the only domain controller that you have that you're recovering, you could just do an authoritative restore of the FSR. That will force the DFSR to rescan the contents of the sysvol and to populate the DFSR database. We will also tell the DID that it has been restored from backup. That will trigger the change of invocation ID. I'm running late, right?
That is correct.
Okay. And the last one, we want to copy the SIS key. Now, for that, I had to write code because there is no command line tool that is capable of doing that. Well, there is no built-in tool that can do that. There are I probably could use one of your commandlets, right? So you can see the original SIS key was 4app something. New SIS key has been updated. We have replaced the SIS key on the server. And, well, last step was we were talking about the security and SAM databases, right? We need a way to replace them. You can't just copy it over. So the only way to do that is to use something, the functionality of pending rename operation. Basically, you can use a command line utility called move file from Service Internal. It will tell the operating system to replace the file on reboot. So basically, when the server will be rebooting, before it actually loads the operating system, it provides you an ability to do some manipulation of the files. In our case, we will tell it to replace the security and SAM registry hives. In addition, we will also tell it to replace the registry hives of network service and local service. But again, this is optional. This is not really a requirement. Okay. And last thing, we probably want to tell the server to use the IP address of the original domain controller, right? So I'm pretty sure it was 114. And we'll tell it to use the second domain controller for name resolution, 2677, and the second one itself. What else? Reboot. And, well, I have a very special slide for this. Reboot. Now, the server is rebooting. At that point, we need patience. Now, this usually takes like 2-3 minutes. So will need to be even. What happens behind the scenes when the server boots? First of all, it replaces the registry hives that we told them to. Oh, here we go. So as you can see, it already thinks that it's domain joined. And let's see. Sorry. And what do you think? Is it a domain controller? So it has the name of the domain controller. It can talk to domain controllers. Is it actually a domain controller? Well,
Is it replicated?
okay. But, well, that could be stale, right? So let's just sync all. It's replicating. It has sysvol. It has netlog on share. Looks like it's a domain controller.